Okay, so doing this the hard way, so to speak, would be if I tried to factor this going 5x, x, and then figure out what goes here and here that makes it work. What's the easy way again? Factor out a 5. If you factor out a 5 out of everything, that makes this so much easier. 5 comes out, and I just have x squared plus 2x plus 1. And you've seen that one before. It's, what would it be? X plus 1 and x plus 1. Because then if I multiply it all back out, I'd get this. So this is just in factored form. And so my roots would be -1 and -1 again. All right. The one on the bottom here is a little harder to factor, but this is just the kind where you had to say, all right, 3x and x. And then the only problem here is that we couldn't say these two numbers will multiply to -2 and add to -5. That doesn't work anymore because there's a number here. But they will still multiply to -2. And if they have to multiply to -2, then there's really only two choices. Where to put the negative. It's like, it's got to be 2 and 1. And one of them has to be negative. And if you know the middle term is negative, then you got to think these two better make my middle term. And because that's going to be the bigger one. And so I want that to be negative. And if I want it to be bigger, I put the 2 there. And get how you can kind of reason it out? All right. And you always check it with first, outside, inside, last, make sure it works. All right, so that's moved us up into the triple ones. We started by factoring things with a single term. And then we went to the double. Now the triple. What do you think's coming next? Quadruple. Or the quadnomials. And we did that with factor by grouping. I'm going to do one for you, and then I'm going to ask you to do one. This is the kind where, I know you learned this last semester, but you've divided it into 2 parts. And then you factored the first part. 2x squared comes out. And then what's left if I factor 2x squared out? This would be a 2x. And then 2x squared coming out of that leaves me what? Plus 1, because really you're dividing by 2x on all these terms. And then, but what comes out of both of these? Something always comes out if you want it to. 1. I can factor out a 1, and what would I be left with? 2x plus 1. And that matches up with that. You remember how that then gets carried to the front? And I have 2x plus 1. And then after I have divided both of these by 2x plus 1, which is really what you're doing when you're factoring, cancel, 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 and what's left? This and this. 2x squared plus 1. Do you remember factor by grouping? All right. Then, if I asked you to finish this and tell me what the roots are, these would be real roots, or actually just one real root. Can you figure it out in your head? You want that to equal 0, right? So then this x would have to be something that's like negative, right? Come on, you can do it. What is it? -1/2. Good. -1/2 is the root there. But this one is not real. I'd like you to try this, please. 2x squared plus 1 has to equal 0. Set it right, just like that. Set it equal to 0, and then solve it. See if you remember how to do that. I notice some kids are good at it and some kids aren't. I need you to practice it right now. So fairly quickly we can get it down to x squared is equal to -1/2. Now, what? Mike? Square root, and I have square root of x squared, which is actually the absolute value of x, equals, and this, I'll just leave this as square root of -1/2. But that is a problem because there's a square root of a negative, right? And that's where the imaginary thing comes in. The absolute value of x just changes to plain old x, and then we change this to plus or minus. And I'm going to break this up into -1 and 1/2. Why? Because that's a nice thing we already know. What is the square root of -1? I. And so therefore, it's x equals plus or minus I root 1/2. How many roots is that? 2, because it's a plus and minus, see? And 2 roots plus the other 1 root we already figured out makes 3 roots, and there it is. There were 3 roots. Fundamental theorem of algebra is happy now. All right. That got kind of long, but you know you didn't even do the factor by grouping thing. I did. So I want you to try just factor by grouping. You don't have to go all the way and get the roots. Just do factor by grouping. If you get stuck, raise your hand. Let me help you. How do we start this one? Oh, there's 2 Maddies. Sorry. New Maddie.
You do the
Okay. X plus 2, I agree. And then factor out this thing. What did you take out of both of them? You are correct. And then what did you have left? And that worked out nice because then that can be factored out. And what do you have next? Now, is that factored all the way? Good. It is not factored all the way. A lot of people, I bet, stop there. Okay, Drew. What is it? Good. Okay, so there's 3 roots, right? -2, 4, and -4. And there's 3 roots, and it makes sense. Yay. All right, that's factor by grouping. That's a review. Here's the stuff we just have been doing in the last day. Rational root plus synthetic. Because, look, it's got 1, 2, 3, 4, 5 terms now. Yet, so you can't do factor by grouping. So, what's this new thing? Rational root theorem. I told you a snappy little way to remember it with F's. Say it if you know it. F con over F co. All right. On this one, I'm going to do this one again, and I'm going to have you do the next one. F con over F co. Factors of the constant. What's the constant? That is. Factors of the constant are, well, the only way to make a 1 is with a 1. 1 times 1. And I can always use plus or minus. And the factors of the coefficient. This is the coefficient. So factors of that are 1 and 2 and 4. Plus or minus, plus or minus, plus or minus. And then I have each one divided by each one. So, am I missing one? Yes.
I was wondering why
All you need to use is the coefficient of the first term. Because there may be some other way to use these, but I don't know what it is. Only the lead coefficient is the important one. I would also remind you that when we were looking at the right-hand side of the graph, it was only the lead coefficient that told us about. So that's the special one. All right. The lead dog in the sled team is always the one that's like the most special one. Okay, so I want my final answer. I take this divided by this. What's 1 divided by 1? 1. What's 1 divided by 2? 1/2. And what's 1 divided by 4? 1/4. Those are all the possible roots. Which one do you think I picked for this? It's either 1 or what? It could be 1 or -1 because you just know I'm not likely to have picked the fraction ones just because they're nasty. But I might have, but I didn't. Okay, so if I'm going to test and see which one works, how do I do that again? Synthetic. That's hence the and synthetic part of this. So I'd like you to try a synthetic now. Just test. What do you think it is? Do you think I should test 1 or -1? What do you think? -1? All right, check -1. Do the rational root quick. Or no, the synthetic quick. I'll pause while you do. Okay, 4 times -1, -4. Add 6 and -4 makes 2. 2 times -1 makes -2. 4 plus -2 makes 2. 2 times -1 makes -2. Makes 1. Makes 1. It worked. Yay. Okay, so what were we doing again? Remember, it's all about factoring. So just because, yay, it works, doesn't tell me much. I need to know, what were the factors for this puppy? Well, this factor is what? X plus 1. Do you remember how to interpret the bottom part? All right. This is how many constant how big the constant is. 1. And it's positive. This is how many x's I have. This is how many x squareds I have, and that's how many x to the thirds I have. So there. But if the goal is factoring, is it factored all the way yet? No, I've just gotten this part simplified, though. I don't have to factor that anymore. And this is a 4-parter. What's our little trick for doing those? Factor by grouping. We just did this one, though, before. Do you remember that 2x came out of both, or 2x squared came out of both of them, and then I had x plus 1, and then I took out 1 out of this one. I had, 2x. 2x plus 1. And then I had factor that out to the front, 2x, that and that come to the front, 2x plus 1. And I'll finish, I think I can still finish this. And there, I have factored it all the way. All right, so that was rational root. Now in the next one, I'll tell you the new stuff.